Here we have a data sufficiency question which says if m and n are positive integers, so there are two informations that we need to absorb. They are positive and they are both integers. Now the question is 4 to the power m multiplied by 1 upon 3 to the power n less than 1? In such questions, the very first step is to simplify the question so that we can understand how the given information in the statement can be put in use. So let me just simplify this. The question is same as is 4 to the power m over 3 to the power n is less than 1. Now since we know that m and n are positive and 4 and 3 are also positive integers, that means the multiplication of 3 to the power n both sides will not make any difference in the inequality sign, because the positive value when multiplied both sides in an inequation does not require any change in sign. Only the multiplication of negative values on both sides requires the change in inequality sign. So if I multiply 3 to the power n both sides, then the question becomes is 4 to the power m less than 3 to the power n. Now this comparison needs to be answered in the form of yes and no, and we must understand that this comparison can be established only if we can compare the values of m and n, and given the fact that positive integers, the m and n are positive integers. Now let's look at the first statement. The first statement is given as n is equal to 2m, so there are several possibilities that we can choose because they are positive integers. So let's start from the smallest possibility, which means if I choose m equal to 1, n will be equal to 2. Second possibility, I might choose m equal to 2 and n equal to 4, and then likewise we can choose several possibilities. The reason is our objective is always to prove that the statement is not sufficient. So that's what we would like to do. Now, why is that objective? I think you can go back to the data sufficiency rules. That is one of the playlists in my YouTube channel and you can refer to it. Now let's look at it. If m is equal to 1 and n is equal to 2, then 4 to the power, on the left hand side we have 4 to the power 1, and on the right hand side we have 3 raised to the power 2, and we know that the right hand side is greater. That means the answer to the question is yes. But if we just go to another solution, and I'm just planning to go to even a bigger solution if that's possible. If I choose m is equal to 3, then I get 4 raised to the power 3 is 64, and here we have 3 raised to the power 6. What is 3 to the power 6? Is 729. Even then the right hand side is bigger, and even if we choose a middle value, although it's going to give us the same answer because we have been going along with the same kind of answers. If I choose m equal to 2, then we have 16 on the left side because 4 the square is 16, and 3 to the power 4 is 81, which means 81 is greater than 16. Every time we are getting a consistent answer, which is definitely yes. And a definite answer simply means that the given information is sufficient to answer the question. That leaves us with only two choices now, option A and option D. Option B, C and E can be ruled out because the first statement alone has proved to be sufficient. Now let's look at the second statement. The second statement only gives us that n is equal to 4, which means since we have to compare 4 to the power m with 3 to the power n, we understand that 3 to the power n is always going to be 3 to the power 4, that is always going to be 81. But 4 to the power m, for m equal to 1 could be 4, which is smaller than 3 to the power 4, and for m is equal to maybe substantially big, if I choose let's say 5, then this will become 1024. 4 to the power 5 will be 2 raised to the power 10, that is same as 1024, and the left hand side, that means 4 to the power m will be greater. Now since we have conflicting answer to the question, which is sometimes yes and sometimes no, 3 to the power n is sometimes bigger than 4 to the power n and sometimes smaller than 4 to the power n, therefore we say that the second statement alone is not sufficient. And since first statement alone is sufficient and second is not, therefore the final answer to the question becomes option A. I hope you enjoyed the explanation. For many such videos, you can just go on our YouTube channel. You can subscribe a course as well from our website on inequality particularly, or on data sufficiency as well. Thank you so much for watching this video.